So in this lesson, we're going to go over the integration techniques. Okay, one thing you gotta know is your trig. Okay, so when we look at this next page, and you need to know all of these rules. Okay, this first one isn't so much a rule as it more as like a property. When you have a number like k, what can you do with that if it's inside the integral and it's being multiplied? Move it to the outside. So that's going to be k times the integral of f of u du, and then you'd integrate like normal, and it would just be multiplied by that number. So looking at the next one, what we're going to do is, this one I don't think is as obvious, but it's really not that bad. You're just going to integrate the first piece, and then you're going to add or subtract or whatever the integral of the second piece. Okay? Break it up, put it into two simpler problems than one big problem. Okay, this next one has been getting people all day, and then they're like, oh, okay, so what's the integral of just du? You guys are so smart. Genius. It's just you. Okay, because really it's kind of like there's a 1 there. So you're saying, what's the antiderivative of 1? Okay, what about when you have a power? Okay, what do you do with the power? Do we add 1 or subtract 1 for integrals? We add 1, and then, like you guys said, the reciprocal goes in front. It is very easy to get integrating and deriving mixed up. At this point, we're just going to keep practicing both, and we're going to get it straight. What about integrating du over u? Or a way that you might be more used to seeing this is like this. What's the integral of 1 over u? Natural log of absolute value of u. Okay, we're not doing that one, just scratch it out. What's the integral of e to the u? It's the obvious. Go for the obvious. Just e to the u. Just e to the u. Okay, if you're thinking, oh, I thought we were supposed to go like times the derivative of u. That's when we take derivative. Okay, but when you're doing u substitution, it kind of all works out. All right. Now, look at these inverse trigonometric. I always have a hard time saying that fast. A lot of times we have A's here. I will tell you on the AP test, it's always a 1. So it's even easier. One of these is arctan, one's arcsine. Which one? The first one is arcsine, U plus C. Okay, some of you, sorry, the second one is arctan. Some of you need to study this. You either need to study it from here or you need to study it from your cards. Both. Okay. Let's go back up to the top and let's do the rest of the just regular trig. Okay, what's the integral of sine?
Negative cosine.
Which one?
Cosine.
You're all second guessing yourself. Okay, from here, with integration, we go up. So we go up, no, you were right. It's negative cosine. Okay, here's the thing. Derivative of sine is cosine. But when you go the other way, you have that negative there. Okay, so what's the antiderivative or integral of cosine? Sine. Okay, what's the integral of secant squared? Tangent. If you know your derivatives really well, this is a lot easier. What about cosecant squared? Negative cotangent. Okay, what about the next one? And the next one?
Cosecant.
Negative cosecant. Okay, for these two, this does equal something, but I don't hesitate to even give you any more rules. But when you are trying to integrate tan and you're thinking, none of the 6 trig derivatives equal just tan, split it up into sine and cosine and then do a u substitution. Okay? and you're going to let u be the denominator. And you're going to get like one of these is like natural log of sine, cosine, one's negative, one's positive. I'm not even going to tell you which one's which, because unless you're really good at memorizing, in which case you can just look it up on the cover of the book. I don't want you to memorize that. I just want you to know when you're integrating tan and cotan, you got to split it up and work the problem that way. Okay, we are going to start with number 1. It has a lot of interesting things happen. Okay, when you're looking at a problem and you're like, I don't know the answer, right? Like if you look at an integral, sometimes you know what the answer is. Most of the time, you don't. So you do a u substitution. And remember, we let u be like the power on e. We let u be the denominator. We let u be something that was inside the radical symbol. So for this problem, what should we let u equal? 1 minus x squared. So then du would be negative 2x dx. Don't forget that du part, because what is this negative 2 end up happening? You divide it out and it goes to the front of your integral symbol. Is there anything else that goes to the front? The 2 goes out to the front, and so those end up canceling. All right, also, don't forget that your bounds are going to change. These are currently x values, and we want them to be a u. So we're going to go 1 minus, instead of x squared, we're going to do 1/2 squared. So what is 1/2 squared?
1/4.
Fourth. What's 1 minus a fourth? 3/4. So then we go 1 minus 0 squared. That's 1. And does any of this look unusual to you so far?
Yes.
Why? Yeah, you guys see this? See how the 1, which is the bigger number, is on the bottom? We need to flip these. So watch what I'm going to do. I'm going to flip them. And that means there's going to be another negative out to the front. And what do 2 negatives make?
Positive.
There we go.
Wait, why is there negative? Because
This first negative was because the derivative of negative x squared was negative 2x. The other negative is when you switch the upper and lower bound.
you have to like change the sign.
Yeah. Because what it does is it puts, when you finally plug the bounds in, it reverses the order of which you subtract them. Okay, what's the power on u? It's in the denominator and it's a square root. Negative 1/2. Okay, so now we got to integrate. We add 1 to the power. We put the reciprocal of the power in front. And then remember, we use the bar here. That signifies that I have integrated and that I'm ready to plug in my bounds. Any questions on how I integrated? Add 1 to the power, take the reciprocal of your new power and put it in front. Okay, so now you plug in the top number first, and then you plug the bottom number in. If we had not messed up, but if we had forgotten, hey, we can change those numbers, the 1 and the 3/4 would be switched, that's what causes that negative. Does that make sense? All right. What's 1 to any power?
1.
So already, what are you thinking the answer is? I know, out of A, B, C, D, or E?
E.
Probably E, hopefully E. All right, this is going to be square root of 3 over square root of 4. Hey, 2 and square root of 4 are the same thing. It is E. Good job. Okay, now what I'm going to do on the next few problems is we're not going to work the whole thing. I'm just going to get it started, because isn't that the hardest part?
Yeah.
Okay, what are you going to let u equal on 2? The denominator? Sounds good to me. What's du? Guys, stay with me here. 2x plus 2. And that doesn't quite look like what we have here. How can I make this over here look like what we have? Yeah, divide everything by 2, basically. Okay, I'm going to leave you to finish that one on your own. Okay, let's look at number 3. If we did a u substitution, which could we let u equal? Any guesses?
X squared.
Okay, we let u be x squared. It's not a bad first try. I kind of have a problem because, like, what do we do with that -4? So this is a dead end. This isn't even Toko. This is, like, weirder. Okay, so that didn't work. What else? Okay, so let's let u be x -4. Then du would be dx. And so we could have, like, a really tough Toko problem on our hands. But there's actually something else we can do that maybe makes this easier, and that is, let's think, let's split this up. So watch what I'm going to do here. I'm going to split it up into x and -4 each over x squared. So x over x squared. And I'm going to go minus the integral, same bounds, of 4 over x squared. And I can even simplify this a little bit further. What is x over x squared simplified to? 1 over x. What is that integral going to be? Natural log. Good. Okay, look at this next one. Sorry. Erase that. I'm going to pull the 4 out to the front. And what is the power on x here? -2. You don't even need to do substitution on this. Once you use the algebra to kind of change the way it looks. Don't forget about your algebra, so I'm going to leave you to finish that one. Okay, next page. Geologist to the right. Okay, that thing is going to help you on number 4 as well. Okay, number 5. This is another problem where if you try to do use substitution, you kind of get mixed up. All right, but I can distribute right there. What would the power on x be when you take square root of x and multiply it to x? 3. How did you get 3/2? You added 1/2 to 1. That's how she got 3/2. Okay, plus. But the next one would be square root of x times 1. There's just a 1/2 there. So I'm going to leave you to finishing that problem up here. Okay, this is not a use substitution problem. This is just add 1 to the power and see how nice and easy 0 and 1, they're our best friends. We like those numbers. Okay, let's do a free response now. I'm going to turn to number 21. You're going to want to write small on this one, by the way, because there's just not a lot of space to do part A. Okay, what are they giving us in this problem? What is that? The second derivative. Y'all see that? They gave us f double prime. What are they asking us to find? Just f. So the way we have to do this is we have to integrate. Okay? If I integrate f double prime, what will that actually get me? Just f prime. Okay, so I'm going to have to go through this process 2 times. Okay, up here, I'm going to use up here just so I don't have to write super tiny. So f prime would be the integral of f double prime. So let's do the integration. Okay, what's the antiderivative of 6x? 6 times 1/2 x squared, and then plus 8x. Are y'all okay if we write that as 3 next? Don't forget plus c though. So I'm even going to go ahead and do that here. I'm going to rewrite this as a 3. All right, now, this is what f prime of x equals. How are we going to find c? Because we have to. We have to find c before I integrate my second time. Like right now, all I have is the first derivative. So they're giving us x. That's nice. They're giving us y. But are they giving us the first derivative? Are they giving us what f prime equals? What does this mean right here? First of all, let's just rewrite this line. Are y'all okay with that? Let's rewrite the line so it looks like what we're used to. Okay, if our graph is tangent to this line, what does that even mean? Or if this is the tangent line, and this line is tangent to the graph. They both pass at the point 0, 2, and what is the slope at that point on both of them? Well, the slope of the line is 3, right? That means, like, this 3 right here, this is the derivative at x equals 0. Like, imagine we had, okay, imagine you had a graph like this. Okay, I'm not saying this is the graph. And then right here. And I said, hey, right there, the slope is 3. Then what is the derivative at that point? 3. That's, I mean, tangent and slope together, that's what derivative is. Derivative is the slope of the tangent line. So this 3 is going to be plugged in for the derivative. That's the hardest part of this problem, is making that lead right there. The rest of it is going to be downhill, because we're going to plug 0 in. Right? We get to plug 0 in because they told us. Everything's happening at this point. So what does that mean C equals? 3. See, 0 is our best friend. We love 0. Exactly. Okay, so that's great. Now I know F prime. Okay, I know what F prime is, but I'm looking for just plain old F. So what do I need to do now? A second time. I need to integrate, and this time I need to integrate F prime. So it's like you integrate, you find C, you integrate again, you find C again. Okay, and these things really aren't too bad to integrate, which is nice. So what's the antiderivative or integral of 3x squared? X cubed. If you wrote a 3 times a 1/3 here, that's fine. All right, plus 4x squared plus what? Plus all right, remember this is all f of x. So that's y, right? So in other words, they're telling us, hey, plug in a -2 in for y. X is still 0. And so what is C? -2. So it's like you use the information to find C. You use the slope of the tangent line in the derivative part, and you use the y value and just the regular old f of x. So my final answer here for part A, I know this is a lot of steps. Like that.
Wait, okay, what did we find at the top?
We found f prime. Excuse me, we found f prime. Got a little choked up. We found f prime. I mean, here's the deal. They gave us the second derivative, and they're asking us for f. There's no magical step to go straight from f double prime to f. You got to kind of like, f prime is like the intermediate step.
Okay.
So we, yeah. All right, let's do part B. So one thing you guys gotta know is when you see this word average value, this is what it means. And that's on your yellow card. Or you need to add it to your yellow card. So in this particular problem, I need to go 1 minus -1, because here's A, here's B, times the integral from -1 to 1 of my f of x. So of x cubed plus 4x squared plus 3x minus 2. So we got to integrate this dang thing one more time. And I'm going to leave you to do that part. Have fun.